So we saw CRUD. We've heard about SQL. Have we heard about SQL? I'll tell you one sentence about it, and then we probably won't hear about it again until much later. It is the standard language that is used to create queries and update statements that are used by relational database management systems, RDBMSs. So says Edgar F. Codd, so-called Ted Codd, who won the Turing Award for his contribution of the relational algebra, which is actually the formal system of relations and how you can manipulate them that is the basis of SQL. So what happens with Rails is that it generates SQL statements at runtime based on your Ruby code. In fact, we can think of this as another example of automatic code generation. Now, before we look at the Rails equivalents of these, very briefly for people who have not seen SQL before, here's a sense of what it looks like. To create something, like adding a row to a table, you would say insert into the name of a table, the names of some attributes, and the corresponding values that go with those attributes. So here I'm actually inserting two rows, one corresponding to myself and another one corresponding to Dave, whose birthday I've diplomatically left blank. How do you read from a database? I say select. Star means when you find any records, I want all of the attributes of those records. And where specifies some conditions, possibly more than one condition, that constrains the search. If I want to update a database, I say update the name of one or more tables, the kind of update I want to do, and which records are going to be affected. So this is saying for any records where the username is Fox, set the email attribute of that record to armandofox@gmail. And to destroy something, I just say delete from some table, and again, I use where to specify one or more conditions. Now, in a lot of early SAS frameworks, the way that you would interact with the database is your app would basically manually construct a string containing the appropriate SQL command, and you would send it over. And in fact, you can do that in Rails, but it's a lot of work that you really don't need to do. We're going to do it a better way. So what does the Ruby side of a model look like? We subclass from active record base, which gives us a lot of useful behaviors that connect the model to the database. And in particular, one of the useful things it does is it makes CRUD operations on the model really, really simple. So let's take a look at an example. OK. So here's my class. Class movie active record base, end. That's the entire class. OK, I haven't added anything else to it. So just those two lines give us some useful behaviors. Let me make this a little bit larger. Now, there's three ways that we can create active record objects. And this works because the constructor can inspect what kind of arguments it got and do different things. The simplest way you can think of, which looks the most like what you've been doing so far, is here. So, class movie, I create a new movie object. I set its title and its rating. Now remember, we previously were using attr_accessor so that we could do that. What we're going to see is that even though the syntax for setting attributes is the same when it's an active record model, attr_accessor is not what's happening here. Okay? So this is one thing you can do. You can create it and set some attributes. I can also, and again, this is a very common Rails idiom, if I pass a block to movie.new, it will yield me back an object, which is the thing that is about to be created, and then I can do attribute setting on that object. And a third way is I can just directly pass a hash where the hash keys are attributes of the model that I want to set up, and the hash values are what I want the values to be. And I don't necessarily have to specify all the values in advance. Now, all we've done at this point is create an object that's an instance of active record. What we've not done is actually do anything to the database. Everything we've been doing so far is just in memory. So we'll now connect it to the database. Convention over configuration buys us this little convenience that given the name of the class, capital movie, we lowercaseify the name of the class and we pluralize it. Why do we pluralize it? Well, because there's a lot of movies. Right? It's really that simple. Plurals just kind of feel like they make more sense. And in case you were going to ask if the name of the class is person, will it say that the name of the database table is persons or people? It'll say people. Yes, that's right. Ooh, magic. But as with all software, it's not magic. There's actually a special piece of Rails called the inflector, whose job it is to understand the pluralization rules, and it's different in every language. Right? So if you have a model called sheep, the table is sheep. If you have a model called mongoose, I'm not sure what the plural is. Okay? But the point is, convention over configuration is such a valuable thing, it's considered such a useful addition, that there's whole subsections of Rails that figure out how to do these things correctly. The database table column names are getters and setters for model attributes. Let me say that again, okay? The table column names that we just created with that previous migration become the names of the getters and setters. That's what we were looking at on that previous slide. I'm about to go back to it. What I want you to observe is that unlike when we were doing @_accessor, the getters and setters don't just modify instance variables, right? So when we're looking at this, here we go, this simple model code up here, there's actually a lot going on. When I say m.title equals the help, it's not just the case that there's an instance variable whose value is being changed. In a moment, we'll see that many, many other things are going on. But it still looks just like the same kind of getters and setters that you're accustomed to. So, creating. Like I said, we created a new object on the previous slide, but we haven't actually saved the object in the database. Those are separate operations. I can do a couple of different things. I can call save on the object, or I can call save bang. Remember that bang is often an indication that this method is dangerous. In the case of save, dangerous means that if something goes wrong, it'll throw an exception, as opposed to the other idiomatic thing to do in Ruby, which is to return nil, right? Most methods, you'll find that you have a choice. You can either use the safe version and check the return value, or you can use the dangerous version and rescue the exception. I could also have just called create. So on the code example, when I finished creating my object in memory and I set some values, I could have, instead of doing movie.new, I could have said movie.create, which is really just a combination of first doing movie.new and then saving the result immediately. And as with save, create has both a dangerous version and a non-dangerous version. The dangerous version with a bang will cause an exception if something bad happens. And once the creation has succeeded, now the object lives in a database. It occupies a row in some table. Now it has a primary key. Right? We mentioned when we were talking about architecture and databases that every table has to have some way of uniquely identifying the items in it. And the most common way is a key or a column in that table whose value is distinct for every row of that table. By convention, Rails uses the name ID to indicate the primary key, and it creates the ID for you. So you don't have to worry about assigning an ID. And given an active record object, x, if you look at x.id and it's nil, or if you call new record on x and you get back false, or sorry, you call new record on x and you get back true, that means x has never been saved. So again, in terms of our example, so whichever one of these methods I use to create the movie object, if I called movie.newRecord ? I would get back true because movie has never been saved in the database. If I then said movie.save, and assuming everything went well, I could then call movie.newRecord again. Now I would get back false. And if I examined movie.id, I would get whichever number happened to get assigned as its primary key, as opposed to getting nil before I saved it. Keep in mind, as you start to see these behaviors, that these objects behave this way because they inherit the behaviors from active record base. Right? So save, create, new record, all of this stuff, those aren't behaviors of Ruby objects generally. They're behaviors of active record objects. And when your model subclasses from active record, you get those things. OK, read, finding things in the database. So as you can see, we're going to go through the CRUD operations one at a time. How do you find stuff? Well, in our very short introduction to SQL, we saw that there's a SQL keyword where that lets you express constraints on the objects you want. And there's a class method inherited from active record that does the same thing. So if I say movie.where and I plug in the name of an attribute and an equality or comparison condition, I will get back an innumerable collection of all of the database rows that match that constraint. I can combine them, right? I can say where release date is less than a symbol, cutoff, and rating equals some other symbol, rating, and then pass a hash saying what values I want to fill in for those symbols. Okay, but the symbols can be whatever you want. I just picked names that I thought were descriptive, cutoff and rating. But any symbol will do as long as every symbol that you mention in your statement has a corresponding value in the hash. Now, why would you do that instead of just doing something like this? For those of you who have been burned by hackers before, you may already know the answer. For those of you who haven't, a sneak preview is, suppose that the value of this string rating came from a user submitting a form. It turns out that clever, malicious users can create some extremely interesting values for this string that will do a lot of damage to your database. So it is bad idea to directly take an untrusted string, meaning a string that came from the outside world and is part of the unwashed masses, and without any qualifying or checking, just kind of shove that string into a statement that you're going to send off to the database. Right? That's the reason that Rails provides these kind of shortcuts. And if you've used other systems, this is often called doing a prepared SQL statement. Right? Instead of building it up yourself, you're using a combination of macros and symbols to build it up. You can chain wheres together. So I could say kiddie movies are those where the rating is G, and old kiddie movies are kiddie movies where the release date is less than 30 years ago or is earlier than 30 years ago. By the way, remember, we saw this already? Remember 5 minutes ago and $5 in euros? This is very common in Rails because, look, you can just see what it does by reading it. It's beautiful. But what's nice about this is that you might think that as soon as I say kitty equals movie.where, this fires off a database query. And now, down here, when I say kitty.where, it's going to fire off a second query or somehow filter the list. Actually, that's not what's going on. What happens is that movie.where doesn't actually touch the database at all. And kitty.where doesn't touch the database at all until I try to do something with the answer. So at the very last possible moment, after you've built up all of your wheres, then and only then, when you try to dereference a member of the collection that you get back, that's when the action happens. So you can chain these together all you want and not worry about sort of flooding the database with needless activity. OK, we're halfway there. How else can you find stuff in the database? A method called find, descriptively named, can be used either to find a movie by its ID directly. And again, there's a dangerous and a non-dangerous version. The dangerous version, in this case, actually doesn't have a bang. It's just plain old find. Dangerous because if the primary key that you include here doesn't exist, then you just get an exception. But you could just say find by ID. That's safe. You'll just get back nil if it doesn't work. There's also a whole bunch of ways that it uses method missing. So if I say find all by rating, the method missing of activerecord will say, aha, it begins with find all, and the word after by corresponds to one of the table attributes. So I will turn that into a query that finds all the movies that have that rating. If you leave out the word all, it'll return a randomly selected movie that matches the criterion of having that rating. And there's a dangerous version that if it doesn't match anything at all, you'll get an exception back. Let's do a quick question before we go on.
Why is it find by ID and find instead of find by ID and find by ID bang?
So the question is, why does the dangerous and not dangerous convention not match these? Why isn't it find by ID and find by ID bang? Here's the way to think about it. Find without any other decoration is its own method. And it is a method that is defined to be dangerous. Like, don't use it unless you really know what you're doing and you're prepared to catch all the exceptions. Find by ID is just a special case of one of these guys down here. It's a dynamic attribute-based finder because ID happens to be the name of the attribute that's the primary key. And all of the find by methods are safe unless you bang them. That sounded great, huh? But does that answer the question? The real reason to think about it is that movie.find is its own thing. But the find by attribute name, these are all taken care of using method missing. That's why. OK, moving right along. Update. So we're up to the U in CRUD. 2 ways to update things. One thing I can do is, just like when I created an object, I would set some attribute values and then I would save it. I could do that same thing, right? I could find an object in the database using one of the techniques that we just saw. I could change the value of one of its attributes, and then I can save the object either safely or unsafely. Or I can combine it all into one call, which is provided called update attributes, which is given an instance of an activerecord object that came from the database, I can just pass a hash of attributes that I want to change and the new values that I want to have on those attributes. And again, I've used the red bang mark to indicate that there is both a dangerous and a non-dangerous version, right? In just about all cases, the non-dangerous version returns nil if something goes wrong. The dangerous version raises some kind of exception if something goes wrong. And these are transactional. So for those of you who don't come from the database world or who haven't worked a lot with databases, they have the nice property that either all the attributes are updated or none of them are. So if you had listed 5 or 6 different attributes within this call, and some of them had illegal values, for example, the call will fail and it'll be as if you had never tried it, right? And we'll find that actually transactions are a property of the database, not really of Rails, but Rails pulls some really nice abstractions into it to allow you to take advantage of that capability very thoroughly. Okay, almost done. We're up to D, delete. It's very straightforward, except that it's called destroy and not delete. I'll tell you why in a moment. Destroy is an instance method, which might surprise you. You might think that you would say delete where something is true, but this actually makes sense when you think about the fact that if you can't find the object in the table, you certainly cannot delete the object from the table. Okay, so the semantics are, you find the object, and once you've got a hold of it, you call destroy on it. That removes it from the database. There's also a method called delete, but the reason that you shouldn't get used to using it is, as we'll see, when you call destroy, there's a lot more that can happen than just the object going out of the database. For example, when we talk about objects being associated with other objects in different tables, for example, suppose a moviegoer has a bunch of favorite movies. Well, if I delete a movie, any moviegoer who had that in their list might need to have some action taken or might want to know about it. And destroy will arrange to call actions that you've defined as, whoa, before you destroy something, do all these things to notify people who might care. Delete is destroy without prejudice, so don't use it. Interestingly, once you've destroyed an active record object, you can still access it in memory. And again, when you think about it, it makes sense, right? When you do movie find by name, what's happening is information is being pulled out of the database and an object is being created for you in the Ruby world that allows you to inspect its attributes and do all kinds of stuff. Just because I delete the database row, I still have this object in memory. Now, in a lot of other frameworks, there's a pitfall where maybe you forget that that object in memory isn't backed by the database anymore, and you try to update its attributes, and then badness 10,000, right? Interestingly, one thing that happens in Active Record is once you destroy the object, you can't modify the in-memory copy anymore. Right? Now, you could think, how could this possibly happen? Well, remember that whenever we see m.title equals something, this is just a call to a setter method, right? We've seen this before. So helpfully, the active record setter methods, once you've destroyed the database-backed copy of that object, the setter methods refuse to work anymore. Right? It's the setter method's way of saying, what are you doing trying to modify an object that you just destroyed? Right? Something, you must clearly have a bug in your logic. And again, it's because of the fact that equals doesn't mean assignment, it's a method call, right? Like we've seen with all of the other things in Ruby, it's just a method call and the method can do whatever it wants. So hopefully you start to see why these fundamental language issues actually help a lot when you try to provide rich abstractions. Okay, so let's go through these. What's happening on this first one? Given that fortune cookie is an active record object, what's the value of this instance variable? Somebody who didn't answer orange. Anybody? Bueller? Okay, trick question. We don't know, right? We don't know. What we've been doing so far in plain old Ruby is when we want an attribute that's externally accessible, we set an instance variable to it. But Active Record doesn't necessarily work that way. In fact, I'm telling you now that it doesn't work that way. So the first one is no good. No good, okay? Active Record is, and this is exactly what I'm trying to get people to remember when they see this, right? Don't get used to thinking that just because you see this, it means, oh, I'm assigning an instance variable. No, no, no. You are calling a setter method. So far, our setter methods have been really, really simple, and all they do is modify an instance variable, but they can do a lot more. Same thing with getter methods, right? So moving on to number 2, self.fortuneText, that's fine, right? Self refers to the instance of the active record object. We said that the accessors on an active record object match the database table names, so this will certainly work. 3 is a tricky one. 3 actually works. Why does 3 work? Because it's using poetry mode. Fortune text is parsable as a method call because it just has no parentheses and no arguments. Okay? This is, and if you remember, this is one of the pitfalls at the end of the Ruby introduction chapter in the book. Suppose instead that I had been trying to set the value of the fortune text field, if example 3 had said fortune text equals embed, that wouldn't work. Because then the attribute, it'll actually be parsed as a local variable name. This is one of those idiosyncrasies in Ruby that you just have to remember and get used to, or it will come back to bite you. So what is the sort of recommended safe thing to do? This is absolutely clear, right? We know who the receiver is. This is a method call on the receiver self. 3 will actually work, but I don't recommend that you do it, right? It works because of poetry mode. In fact, if I had put a pair of empty parens around fortune text, that would have made it clear, right? So what's the moral of the story is, don't misuse poetry mode. Okay? Poetry mode is good when it eliminates clutter, but poetry mode is evil when it results in an ambiguity about what your code might actually mean, what you're trying to do.